Hi, I'm Raymart, and the paper I'll be presenting on today is called Game AI as Storytelling. In early research and development of artificial intelligence for games, the main goal was to implement agents that were competitive and had the goal of winning. In the 1950s, one of the earliest efforts of research looked into game AI for computer chess. Similar to chess, mainly adversarial zero-sum games were researched early on, and mostly minimax strategies were implemented. The strategy uses some form of an evaluation function to determine the expected payoff as a result of some action. Hence, the strategy strives to make the most reasonable actions that would maximize or minimize the payoff when reaching the end of the game. These approaches later spread to different forms of games, such as first-person shooter and role-playing games, but they all still had the main goal of winning the game. Now, within modern games, we see developers advocate more for increasing player engagement and enjoyment. As a result, we now see the design of game AI growing in its responsibilities to include making the game experiences for players enjoyable. However, game AI that focuses on player enjoyment tends to make some sacrifices, and this leads to less competitive agents and less computational resources allocated for them. Game designers are able to make decisions on the types of experiences that players enjoy and encounter during the game. Oftentimes, they design a set sequence of challenges and other events that players are led through as they progress through the game. However, not all players will have the same interest while playing through a game, so there becomes limitations on the extent to which designers are able to make the game customizable for the different types of players while still keeping close to their intended storyline. This leads to player agency, which is the ability for players to do pretty much whatever they want, and customization, which involves having various experiences to play towards the preferences of the player. And so player agency and customization are hard for game designers alone to entirely address during the game design and development process without actually having players to play the game. And so this leads into research areas for making intelligent systems for games that are able to take on such functionalities. And now, so looking into some of the motivations for how to go about designing such game AI, we look at narratives. So a narrative can be described simply as a sequence of events. I found it interesting when the authors mentioned how narratives can be described as a tool for humans to better understand the world they live in. This plays into how narratives are used by game AI for making games enjoyable. And so the two main parts of a narrative are the fabula and the suzette. The fabula consists of all possible events in the world, and the suzette is a subset of events that produces a narrative sequence. These foundational concepts and ideas associated with narratives are realized in how narratives are represented and generated within the game. And so narratives are represented in what are called narrative plans. And so the authors looked at narratives as a directed acyclic graph in the form of what is called the partial order causal link POCL plan. In this graph, the nodes are representing the actions or events within the story, and the edges are either causal links, which are predicates that must be satisfied within the story, or temporal links, which capture time constraints in which action events must occur in. And so a narrative plan, such as the one shown here for Little Red Riding Hood, contains the events and actions to be initiated by the player and characters in order to portray a particular narrative for the story. So in this narrative plan, we see that events and actions are found in the boxes, and the causal links are these solid arrows, and the temporal links are dashed arrows. And there is an initial state and a final outcome event for this narrative. And here we have two author goals, which are just predetermined events that the author has intended to be experienced before reaching the end of the story. And so with this representation, there's also a form of constructing these so-called plans. So in our representation of narratives, there is a domain library or a domain theory, which essentially is a library of all the actions and events within the world. This is similar to how the knowledge base for rules-based agents consisted of the information within the game. Below, there is an example of a couple of event templates for the Little Red Riding Hood narrative example. We can see that the structure is similar to how the rules were formatted for the rules agents, as there was the conditions that had to be satisfied and then the events or actions as a result. And so when generating a narrative or plan, we are interested in finding a sequence of events from the initial state all the way to the terminal goal. And so one algorithm used for plan generation is the partial order planning algorithm, or POP. So in summary, this algorithm inspects the plan and iteratively tries to find any flaws. And when there are flaws, we try to make revisions to the plan and resolve them. So the possible flaws are open conditions and causal threats. Open conditions are preconditions in an event or action that have not yet been satisfied. And causal threat occurs when the temporal constraints do not preclude the possibility that an action with an effect C being false occurs between two actions that have a causal link that requires the effect C to be true. And so this planning algorithm could be used to develop narratives when given a POCL plan for a world or story. The concept of an experience manager was first proposed by Laurel in 1986 and then further investigated by Bates and colleagues in 1992 and 93. An experience manager is an intelligent system that is able to operate on the game world in order to make game experiences more enjoyable for players. The experience manager is also able to compute sequences of game states, also called trajectories, through this game state space, and these trajectories can then be connected to potential narratives for the game. And the automated story director framework is the experience management framework discussed by the authors. And this framework is essentially just their implementation for an experience manager. This framework has the ability to generate alternative narrative plans if the player makes actions that deviate from the designer's narrative. The framework makes use of contingency trees, which are graph structures where the nodes are narrative plans and the branches are alternative narratives as a result of player deviations or inconsistencies. The root node of the contingency tree is called the exemplar trajectory, which is just the default narrative designed by the game designer. This framework also has implemented a tiered replanning strategy in order to resolve inconsistencies. So the image on the right here shows some of the processes of the replanning. So the general idea is to consecutively apply 4 strategies that the authors described in this framework until one of them produces a satisfiable alternative narrative plan. So here's an example of a contingency tree for the Little Red Riding Hood example. The larger narrative plan on the left is the exemplar trajectory, and the branches represent alternative narrative plans generated based on certain inconsistencies that occur. So in here, in this example, branches are created as a result of the wolf dying before reaching the end of the story. And so the alternative narratives attempt to find a way to revive the wolf in order to progress the story to the end. The authors also discuss the passage system, which provides a way for the computational system to model player behaviors. The main idea behind player modeling is to be able to learn about the player and make informed decisions to impact the player's experience in a positive way. The passage system models the playstyle of the player based on Lawes' theory for role-playing games. And so a vector of scalars is used to capture the extent at which the player exhibits each type of playstyle. And here there are 5 playstyles modeled. First one, fighter, occurs when players enjoy combat. Method actors are players who enjoy having their personality tested. Storytellers are players who enjoy complex plots. Tactician are players who enjoy thinking creatively. And the last one, power gamer, are players who enjoy gaining special items and abilities. So the system makes the assumption that players enjoy experiences that closely relate to their preferred playstyle. And so the goal is for the narrative plan to have the most actions and events that capture the player's modeled playstyle. And this is accomplished by annotating all the game actions and events within the world with their playstyles that they inhabit. This allows a utility function to be used in order to calculate an expected value for the type of playstyle portrayed by an overall narrative plan. This also provides the added benefit of multiple contingencies being computed for every possible inconsistency beforehand, which alleviates some of the computational time. And now, narrative trajectories can be optimized based on the traits of the player. The graph on the left is an example of a contingency tree that uses decision nodes to branch from the exemplar trajectory using information about the expected playstyle portrayed. So to recap, there is a growing trend to design and develop games with greater player agency and content customization. This requires computational approaches to be considered in order to offload the responsibility for engagement and enjoyability in a game from the game designers. In this paper, an automated real-time experience management approach was designed and that leveraged correlations between narrative and experience. This framework further suggests that games should look into game AI for storytelling whenever the experience of the player is most important. So some of my personal thoughts, I found this paper to be a great overview about experience management. So the description of how narratives and how player behavior was modeled, um, as well as the example using Little Red Riding Hood, helped to deepen the understanding for these concepts. Um, and also the work on game AI for player engagement and enjoyment is useful and practical as we know that preferences vary between different players. And so having an automated system to help with that game design decisions is very valuable when trying to, attract more players and make them enjoy playing the game. The potential research for areas of player modeling and narrative generation, I think can be very fascinating, such as possibly extending the play styles to capture more different styles or potentially different approach to modeling the player behavior. Also, possibly looking at different ways to represent narration for games and how to search for potential narratives in the game state space. So yes, that's my presentation. Thank you.